All right, hello out there in geometry land. This is section 7.4, parallel lines and proportional parts. So now what we're going to talk about today first is something called a midsegment, and then we're going to move into talking about all these different properties of things with parallel lines. So take a look at this first figure here. Inside our box, we have triangle ACB. And if you notice that we have the DE going across, and what that does is it cuts it into two triangles, one small one on top and the big one ACB. So let's talk about this first, and then we're going to look at a whole bunch of different models and how we can use these different properties. All right, so the segment that connects the midpoints of two sides of a triangle is called the midsegment, and it has two properties. All right, so here we go. Midsegment, boom. Right there, DE, that's our midsegment. And we know it's a midsegment because we have CE congruent to EB. That means that this point E right there is the midpoint. And similarly over here, point D is the midpoint. So that's why we call that the midsegment. Makes sense. All right, now here's what we know about it. It's parallel to the third side, which means right here this does a lot for us. That DE right there, midsegment, is parallel to AB right there. That's what we're talking about the third side. It looks parallel. This is obvious. Okay, think about it. It makes sense. Again, parallel to the third side. And then the other thing is that it's also half as long. Okay, so AB is twice as long as DE. And that makes sense, again, because it's the midpoint. So each of these pieces are half. And then this is half of that guy. All right. All right, so if CD equals DA, there we go, that's given, and CE equals EB, then we know that DE is parallel to AB. That's our midsegment. We already marked that in our picture. And we also know that DE equals 1/2 the measure of AB. So we'll just write 1/2 times AB. All right, there we go. And let's fix it, make sure you see that that's a 1. All right, DE is parallel to AB, and DE is 1/2 of AB. All right, so let's take a look at a couple quick examples. I'll leave that piece up for you there. All right, so now what we see here is a midsegment, and we know it's a midsegment here because 6 and 6, those are congruent. 5 and 5, those are congruent. That means we have two midpoints, we have a midsegment, and remember, this is a really easy direct application. Our midsegment is half as long as this. So if this is 7, then x here is 7 times 2, which equals 14. It's that easy. If we're given that information, that's it, and that's all we have to do, okay? All right, let's look at our second one now. Now again, we're given congruent, 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 congruent. So we know that this is the midpoints here, midsegment here. This is easy too. This is 26 we're given here. We know that y, then our midsegment, is 1/2 of that base of the triangle, or that third side. And that means that y is 1/2 of 26, or y equals 13. All right, I'm going to scroll down. So if you need to see those, look at them a little longer, pause your computer, and I'm going to scroll down to examples 3, 4, and 5. All right. Now, we get a little more complicated here, but check it out. We're noticing this trend here. What do we see? Congruent, 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 congruent. That means this is our midsegment right there. Now, here's what we know about the midsegment, is that it's half as long as this third side. So that means that our midsegment, which is 2x plus 5, sorry, this pen is not writing very nicely for me today, so let's try to get those to look a little cleaner. All right, equals 1/2 of that triangle, side of our triangle, or the base of our triangle, 6x minus 16, or minus 14, excuse me. And we set up a nice equation. So we don't know either of the values, but we're doing the same exact thing. Above, we knew that was 26. We took half of it to get 13. Now we have an expression. We take half of it to get our other one, and now we just solve our equation. So let's distribute that 1/2. 1/2 times 6x is 3x. 1/2 times 14 is 7. And we still have 2x plus 5 over here. All right, and now solve for x. Minus 2x. Minus 2x. I get 5 equals x minus 7 plus 7 plus 7 And boom, we are done, and we get x equals 12. There we go. All right, moving on to example 4 here. All right, this one looks a little weird, okay, but let's see if we can make sense of this thing right now. There's actually a lot going on here, okay, and we have to think about what we know about these triangles. So right now, what we see here is that we have a midsegment JH. That means that we know JH is parallel to KM, okay? It also means that it is half of KM. And that means if these two pieces are congruent, it also means that JH is congruent to one of those pieces. So let's mark that congruent. Still parallel. Okay. So now what we see here is we have these parallel lines. Now I'm going to throw a lot of stuff out here. Let's see what you guys remember about congruent triangles, proving two triangles congruent. Okay, so I'm going to mark a few things in our triangle. I have a parallel line, okay, and this angle right here and this angle right here are created by this transversal and my two parallel lines. Those are corresponding angles. So there we have two angles that are congruent. Okay, now we have those sides congruent. Now, we also know that if JH is that midsegment, then that tells us that this side must be congruent to this, or that piece must be congruent to that piece, because J is the midpoint. So look at what we just did. We created two congruent triangles, and now we know that triangle LJH is congruent to triangle JK. And let's call this point Q, just so we name it. So there we have our two congruent triangles, and now we can use anything else we know. So now if we know that that side is 30, we know that these are congruent, and that's 15, and that's 15. Now check out my congruent triangles that I just proved. That means that side must be congruent to this side because they're corresponding parts, and that means x is 15. So there's a lot going on with that one. Most likely you're not going to see that one that challenging, but there's a lot of cool things to talk about there using our parallel lines and congruent triangles. All right, now this next one, example 5 with triangle KLM, it looks like there's a lot going on. Here's the key, is just seeing what you're given. Look at this, guys. JH is the midsegment. So remember what that means is that JH is 1/2 of that triangle's base, 1/2 of LM. Now check it out. If we know that this IM is 8 and this is 8, that means that's 16. So that means that JH is 8. And there's no work to do. We just have to notice, remember that property that it's half of it, and we see it there, and that's it. No more work to do for that one. All right. Pause it, go back if you need that example longer, if you need to play that again. Okay? All right, so our next thing here we have, if a line is parallel to one side of a triangle and intersects the other two sides, then the line divides the other two sides. Now, be careful here because we don't know that that line is the midsegment. We just know it's parallel. So if BD is parallel to AD, we don't know that it's the midsegment. So, but we do know it divides those sides proportionally. So what we can do now is we can set up proportions with these two sides or these two segments. So what we do is we take same thing we've been doing with some of our triangles. Think of these as kind of proportional parts, BC, and we're going to make a proportion over AB. So it's what's above that parallel line BD and then what's below it on the same side. And now it'd be consistent, being consistent, BC is on top, so I put CD on top over ED. And we're going to make a proportion and solve like that. This is commonly called the side splitter theorem because we're splitting those two sides into proportional parts. Okay, so let's take a look at example 6, 7, and 8. Okay, and again, just a really quick application here for example 6. Take that top part, x, over the bottom part, 12, equals the top part of the other side, 4, over the bottom part, which is 8. All we have to do now is cross multiply and solve. And you may notice 4 is half of 8, so that means x is going to be 6 for this one. All right, again, example 7, same idea. All right, take a second, try to solve this one on your own. Pause it if you need to. Set up our proportion. And now look at it. We're splitting this side. So if I take n over 25, be consistent with my proportion. I started with n, this top part. That's going to be 6 then over 20. So there's my proportion. Again, all we have to do now is cross multiply and solve. And we get n equals 7.5. All right. Next one, example 8. There's a little bit more going on here, but let's go ahead and set it up and then stick with the algebra here. So top part, I'm going to put it up here in this space because I have a little more room to work. X over the bottom part of that same side, x plus 12, equals top part of the other side that's split over. Now, I don't want this whole side 33. If I know that's 11, that's 33. I subtract 33 minus 11, gives me that piece. I want that piece, not the whole side in this case. Okay, so there's my proportion. Now I can go ahead, cross multiply and solve, and let's go ahead and do the algebra for this one. Cross multiply. I'm going to move down here now. We get, actually, what's right here? 22 times x equals, now remember, if you have an expression here, put it in parentheses before we cross multiply. 11 times x plus 12. There's our cross multiplication. Now we have an equation we can solve. Distribute that 11. I'm going to jump down here. 22x equals 11x plus 11 times 12 is 132. Okay, now solve for x. Subtract 11 from both sides. Sorry, subtract 11x from both sides. And 11x equals 132. Divide by 11. Divide by 11. We get x equals 12. Mine doesn't quite fit on there. X equals 12. All right, and let's erase that. All right, take a second, look through that work, make sure you're good with setting up the equation. That's the key to these, is seeing those proportional parts. All right, pause it if you need to, go back, make sure you're good with those examples. All right, let's move on. We have examples 8, 9, 10, and 11. All right, now again, this is really straightforward, but look at what's given here in example 9. I have that 4 is that small piece, 12 is the other piece on that side, x is one piece, but now I know the whole side is 20, so I need to make an expression for this. I'm not going to use 20, I need that piece. The whole side is 20, the top piece is x, or the left piece in this case. That means that piece that I want is 20 minus x. So I'm going to set this one up for you, then you can go ahead and solve. 4 over 12 equals x over 20 minus x. Piece of cake, all right? Cross multiply and solve, and you should get, for this one, x equals 5. All right. Next one, exact same thing. You guys are up to this one. Take care of this one on your own. Exact same thing. Work it out. And you should get y equals 15. Pause that. Work that one out. Make sure you're good to go. All right. Example 11. We got a little bit more going on here. But again, look at what we have. Two parallel lines. Take that top part, 18, over the other piece of that side, over 6. Top part of this side, x plus 22. Over the bottom part, x plus 2. It's fine that we have those two x's. All we have to do now, cross multiply and solve. All right. Again, I want you to practice working this one out on your own. Cross multiply and solve that. Make sure you're good with the algebra. Ask for help if you're stuck here. Okay. You should get x equals 8. So check that one on your own. We've got a lot of examples here, so you guys need to be working on your own. All right. Go back and pause that, work those ones out if you need more time. Example 12. Now, this is asking us to determine whether it's parallel. We don't know it's parallel right now. But if the sides are proportional, or those pieces are proportional, then we know that it's going to be parallel. So we can prove it. Okay, so what we're going to do is we're just going to set up two ratios and see if they're the same. So take that top piece, 60 over 20 equals 3. All right, take that bottom side, 48 over its piece, 16. Again, simplify, equals 3. Yes, the proportions are the same. So that means our conclusion is that that segment QR is parallel to the side ST. All right. Same here with example 13. When we set up our proportions, we're just going to check the sides. 15 over its other piece, 21 on the same side. If we simplify that, we get, and I'm just going to put the decimal here because this is an easy way to check. Put it in our calculator, I get 0.71428, and this keeps going. All right, take my other side, 17 over 23. Put it in my calculator, check the decimal. If it's the same thing, they're proportional and it's parallel. 0.73, right away I can see they're not the same. That one keeps going as well. So that means that SA is not parallel. So we do the parallel sign, we draw a slash through it to NT because they do not split those sides at the same ratio. All right, now here we go. We're looking at more parallel lines. This idea is exactly the same. It doesn't matter that it's not a triangle. But look at example 14. It is a triangle. Now there's just 3 pieces. Now the good thing about having 3 pieces is now we have choices that we can make. Okay? But here's what's cool. Think about this like the midsegment theorem. These are all congruent, right? Congruent, congruent, congruent. That means, since these are parallel, that these parts are also congruent. Okay? Just like the midsegments. So now we can make 2 very simple equations. Again, we have some nice choices here. So we just take 12, and we know it's congruent to each of those pieces, equals 2x minus 6. Solve. 12 equals my other piece, x plus 3. Because they're all the same. Solve each one of those. Here's the easiest one. Minus 3, minus 3. 12 minus 3 is 9, and 9 equals x. And if you solve this thing, you better get the same thing. All right. Next one. Okay, this looks kind of weird, but again, look at the pieces here, guys. Parallel lines, piece, piece. Okay, set up my proportion. 3 is that top piece over x, kind of same side or same transversal in this case. 4 is the top piece. X plus 4 goes on the bottom. That's it. Cross multiply and solve. Remember, before you cross multiply, put that in parentheses so you remember to distribute your 3. Pause it, solve that, check your answer. Should get x equals 12. All right, pause that if you need more time. All right, moving on, examples 16 and 17. All right, we should be getting the hang of this. Now, this looks kind of weird. I got x's and I got y's. But check it out. Here's what we know. Look at what we know and make an easy equation. These are congruent. If those are congruent, that means that 2x plus 4 is the same as or equal to 3x minus 1. That's easy to get x. So my question is, how do we get y from there? Okay, so go ahead and solve for x here. You should get x equals 5. Now, how do we use that to find y? Do we need to use that to find y? Okay. If these are congruent, since these are parallel, it means these must be congruent. So I'm just going to set up a whole new equation. All right, look at that. It's just like our midsegment again. So my new equation with y, 3y equals 2y plus 2. And again, solve for y. This should take you a couple steps. We should get y equals 2. All right, example 17. Same idea. All right. look at the pieces. Okay, I'm dividing this one. I'm going to take x plus 12 over 12 equals my other line now. I'm dividing, and I have 5x over 3. There's our proportion. All right, let's go ahead and solve this one because we haven't solved them for a while. So let's practice. Cross multiply. Five x times 12. 5x times 12 gives us 60x. Distribute that 3. 3x plus 36 minus 3x. Our x is on the same side. 36 equals 57x. Then we divide by 56. Don't freak out. It's okay. We're going to get a fraction for answer. Let's just simplify. Looks like 3 goes into each of these, so we can divide each one by 3, and we'll leave our answer as a fraction in the simplest form, 12 over 19. It's fine to get a fraction. We don't always have to get a whole number. All right, pause it if you need more time with that. Okay, so notice all these things are the same so far. They look different, but they're all the same so far. All right, now here's where it gets a little more complicated. All right, look, we have it here. More complicated. Because we have a piece. This is where it's different. We can't use the side splitter idea because side splitter is a piece and a piece and a piece and a piece. That is a whole side of this triangle. That is a whole side of this triangle. So as we look at it now, C is a whole side of this small triangle. That's why it's called, we can call it the L method. See that kind of backwards L there? Now, when we compare these things, we're looking at whole sides of the triangle. So this is a whole side. Not just D, but C plus D. And B is a whole side. Okay, so see that? We need to be thinking now, whole side to whole side. Okay, these are similar triangles, so we set up the ratios exactly like when we're working with similar triangles. Don't get it confused with side splitter because we're not splitting the sides in this case because we have whole sides. All right, so check it out. Whole side, whole side. Now, as we look at these things, make sure when we set these things up that we're setting up our corresponding parts. Whole side, whole side. Okay, so when I set up my ratio now, I'm going to go my whole side here, x. X corresponds to that side 3 in the small triangle, equals. Now my whole side is not 12. My whole side is 12 plus 6, or 18. That's that base of that larger triangle that I outlined in blue. Whole side of the smaller triangle is 6. So there's our proportion that we're going to set up. Now all we have to do again, cross multiply and solve. That's the name of the game here, guys. X over 3 equals 18 over 6. 6x equals 3 times 18 is going to give us, let's see, 36. That would give us 254. Divide by 6. Divide by 6. X equals 9. Okay, so here's the key again. Seeing those triangles. Seeing those overlapping triangles. All right, so let's look at this next one. I'm going to let you set this one up so you can check. All right, now notice again, the parallel lines are there, but this is a whole side. Okay, this is a whole side of the big triangle. Okay, this is a whole side. This is a whole side of the small triangle. Okay, so when we think about that whole side of the big triangle, it's not just y, it's y plus 20. That's the whole side. All right, set it up. Whole side of the big triangle over corresponding side of the small triangle equals whole side of the big triangle over corresponding side of the small triangle. There we go. I'm going to let you take this one, cross multiply and solve. and we should get y equals 4. Pause it, work that one out. Take your time. All right, let's look at our next one again. Identify my sides. Okay, whole side of the big triangle. Whole side of the big triangle. That is x. That whole side of the big triangle. That's what we want, right? Now, here's where we got to be careful. Because when we look at our small triangle, okay, we have whole side of the small triangle, whole side of the small triangle, but we need an expression for that. So if this whole piece here is x, this little guy is x minus 20. See how we get that? We take that whole side, we subtract that 20 that we know. That's the expression that we need to use now when we set up our proportion. So again, let's get our proportional parts. Corresponding parts, 40 is the whole side of the big triangle, 15 is the side in the small triangle it corresponds with. Now we, again, look at the whole side of the triangle is not 20, is x. The whole side of the small triangle, we made that expression as x minus 20. There's our proportion. Now we can go ahead, cross multiply, put this in parentheses, cross multiply and solve, pause it. All right, you should have your answer now. X equals 32. All right, go back if you need more time. Again, we got a lot more examples here, guys, so if you're not quite getting it yet, that's okay. We're going to practice some more. Again, the idea here is to make sure, look and check, are we working with whole sides or are we working with splitting sides? So here, x is a whole side of the large triangle. Here's the other side of the large triangle, whole side again, right? So that whole side there is 12 plus 9, which is 21. That's what we're going to work with. Now let's look at our small triangle. 8 is a whole side. 9 is a whole side. Okay, that's what we want. So when we set up our proportion, this one's pretty quick. X over whole side of the corresponding small triangle is 8 equals whole side of the large triangle is 21. Corresponding side of the small triangle is 9. There we go. Cross multiply and solve. And I got a decimal on this one, so double check me. 18.6 repeating. Okay, don't round it. Don't drop that repeating sign. All right, 22. We got a little bit more going on here. We got an x and we got a y. So what we got to figure out is what's easier to solve first. Okay. Now, in this case, we do have a side splitter. We have x as a piece, 16 as a piece, 5 as a piece, 20 as a piece, and these are parallel. So we're going to use side splitter first. Be consistent with how we set it up. 16 over x. There's my two pieces of that side, equals 20 over 5. There's my two pieces of that side. Cross multiply and solve. You guys know the name of the game. Check your answer. I got x equals 4. Now that I know that x equals 4, now we can use our proportions for the triangle to find y. All right. We can use either triangle. Actually, let's use what they gave us. If we check this out, whole side, that's 25. Okay. Now look at my small triangle. Whole side, whole side. So when we set that up, we're going to set it up y over 25. Sorry, let's be consistent. We could set it up that way, but let's do our corresponding side again. So I'm going to do y over corresponding side of my small triangle is 12 equals our large side, our side in our large triangle, 25. Whole side in our small triangle is 20. Cross multiply and solve. 20y equals 12 times 25 is going to be 300. Divide by 20, divide by 20, and we get y equals 15. Beautiful. All right. Example 23, same exact thing. You're on your own for this one. Okay. Make sure you're identifying where do I use side splitter, where do I use the proportions for the similar triangles. Pause it, work this one out. All right, you should have paused it, so we're checking now. All right, so I did y first with side splitter, then I got y equals 24, then I did x with my proportional triangles because x is a whole side. not being split, so make sure you're using whole sides. If you didn't get 30, double check, make sure you used whole sides for when you set up your proportions. All right, lots of problems here, guys, so hopefully we're getting it. We got just two more. Example 24. Now, again, we know these triangles are similar. So if we know these are similar, now we can set up our proportions, okay? But again, we can't use side splitter because this is a whole side. So we use whole side, okay? Identify those corresponding parts, whole side, 10 plus 20 is 30. That's what we're using. So when we set up our ratios, 30 in the big triangle corresponds with 10 in the small triangle equals, now go to whole side in the big triangle, x plus 26 over whole side corresponding in the small triangle is 22. Okay, there's our setup. Again, make sure you're good with this, guys. All right, and when we solve, we get x equals 40. Now, be careful here because we're not done. It asks us to also find the length of DE. All right, so DE is not x. DE is x plus 26. So that means we have to take that x equals 40 and add the 26, and we get DE equals 66. Take a second, check your work, make sure you're good. All right, one more here, we're matching it up. Now, when we have matching, let's see if we can use our answer choices with what we know, okay? Now, here's some things that we know, okay? We have parallel, 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 which means these sides are going to be proportional. So that means that if this is 4, this is 6, this is 4, that means this FG has to be longer than this one and this one. Now, if these are the same, those are both 4, that means these have to be the same. That's 6, that means this guy has to be 6. So there's EF, that's the easy one. We don't even have to do any work for. Okay. Now, 6, 6, now we can set up our proportion, and we're just using side splitter again. So we're using these pieces. So 6 over FG equals 4 is AB, that's that top piece, over 6 again. Cross multiply and solve. 6 times 6 is 36 equals 4 times FG divided by 4. We get FG equals 9. There we go. That's A. 9. Okay, now we have these other parts. What do we need? Let's see. ED is right here, is that base. And then we have FC is that guy. And now let's think about this and let's look at our diagram, right? What's happening? This is smallest. This is the next biggest. This is the next biggest. That means ED has to be the biggest one, which is D. And that means that FC has to be the smallest one, which is B. Or the smallest one left, I should say. All right, so use your choices when they're there. All right, nice work. A lot of problems here. Hopefully you guys got it. Move on to that practice. Nice job.